Friday we had stepped into lessons 12 and 13, and now we're kind of going back to 11. So remember, sometimes our numbers don't go in order. Miss Megan and I will sometimes change the order. Sometimes the order doesn't matter, and sometimes we think it's an order that would make more sense. So that's if the numbers bother you not going in order, that's what's going on. Okay. All right. So Monday morning, nope. Tuesday morning after fall break, we're raring to go. Y'all are excited to be here, good and awake. Because if y'all look sleepy, then I'm going to look sleepy, and we can't have that. Okay. So we're going to work together to be awake. Okay. All right. If you think back over the last several days that we have been here, we've been working on multiplication. Okay. We've been working on learning to multiply bigger numbers, right? And we have done several different ways. Can you help me remember what are some of the ways we've learned how to multiply multi-digit numbers? Some ways you might have liked and some ways you might not have liked so much. What's one way?
Standard
algorithm. All right, standard algorithm. Okay, which is what we have. That's the last thing we've been doing. Yeah. Partial product. That's where we multiplied each place value and stacked them up and then added all of those numbers. Partial product, standard algorithm. There was one more, and I don't know if anybody would call this a strategy, but you might think of a tool that we used. What tool did we use? Yeah. The place value chart, okay, and we multiplied on the place value chart, making those dots or discs move down the chart, okay, and so we have worked on all those ways, and we were, like I said, we left off with the standard algorithm. Standard algorithm today, that regular way, is going to be a way we use today to check our work, okay. We are going to look at a whole different method today that I do want you to try today. Some people really like it. Some people would rather stick with the standard algorithm. But we need to see this model because this model gets used a lot in some of the work that we do. And so we need to understand what it is. It just says I can connect the area model and the partial products method to the standard algorithm. Okay, and so we're going to see some of these things side by side, these different ways of doing this, just to understand a little bit better about how they work, okay? But the area model is what we're calling it today, the method that we're using today. Okay, so that is what's coming. Let's jump here. Well, no, I don't want to jump there today. Let's jump. No, not that either. Let's jump here. Sorry. Jump around a little bit. Let's get our minds going. We didn't do a sprint. Maybe that would have been better this morning, but we haven't done one of those to kind of get our minds going. But let's think here. Oh, don't yell things out. Let's raise our hand. I am going to ask everybody to answer that first one. What is 2 times 2?
4.
Okay. So that's 4. What about 10 times 2? Yeah. 20. What about 300 times 2? Yeah. 600. Now, if you did not see that right away, remember you can imagine these. If we did, hold on, I'm going to write it wrong. If we had written it 2 times 300, you could picture those 2 digits getting multiplied. 2 times 3 is 6, and then add your 2 zeros. So we know the answer there is 600. About 4,000 times 200.
2.
Yeah, I'm going to have Monday math today, so even though it's Tuesday. What is 4,000 times 2? 8,000. Okay. Same thing. This digit times this digit is 8, and then 3 zeros. Okay, and then last one. This is going to take thinking a little bit to keep your numbers straight, but you can picture that problem like this. Okay. Thank you, sir. If you'll just here. Just have to put it right. There you go. 100 feet. Okay. And there's a thing right here. So let me know. I found it. Okay. So in your mind, imagine the problem turned that way. Okay. All right. So you got
8,624.
8,624. Anybody agree or disagree? If that's, several of you had your hand up. I didn't know if that's what you were going to say as well. He said 8,624. Is that right, what you said?
Yes, ma'am.
I think that's what you said. If we came over here to check ourselves, 2 times 2 is 4. 2 times 1 is 2. 2 times 3 is 6. And 2 times 4 is 8. Didn't have to carry one time. Okay. Question?
It's easier because it's right there. I don't think it's plus 800 plus 600 plus 20 plus 4.
Anybody else catch that?
Huh?
That this problem right here, these are the partial products for that. Anybody else catch that? This is the number put all together, but here's the thousands place, here's the hundreds place, here's the tens place, and the ones place.
So all you have
Pretty
to do-
observant for a Tuesday morning after fall break. Good job.
All you have to do is just add the numbers.
And did you wind up adding them because of that? Yeah. If you saw that, then all you had to do is add those. Because these have already been multiplied, you just add those pieces together like you do partial product. Okay? All right, so let's move on. Now, we've gotten our brains warmed up a little bit. This is going to talk to us about using that area model. Now, area. Do we remember about finding area? You think Miss Elizabeth still needs this?
No.
No, you don't think so? Okay. I don't always venture off into these boards on the side, but I'm gonna do that just for a second. If I were to draw a rectangle, and if we were to say that this was 3 units and this was 5 units long up here, what would we do to find the area of that rectangle? Think back just a few days what we did. What do you think, Bailey? Okay. Area is the length times the width. So the length times the width is 5 times 3. So 5 times 3 is what, everybody?
15.
And then this would be 15 square units. Okay? So we know to find the area of a rectangle, we multiply the length times the width. Now that's going to come into play with our area model. Draw a rectangle with the length of 8 and the width of 200. That's a larger rectangle, isn't it? Making sure that's not what they've already, yeah, it is. Okay. Find the area and write it inside the rectangle. Well, what they've done is on the next slide, that's what I was just double checking. So here is the rectangle. It is 8 in width and 200 in length. Now when you multiply those two numbers, okay, that shouldn't scare us too bad because 8 times 200, 8 times 2 is what?
16.
16 plus the 2 zeros. And they've already written that answer inside, 1600. Okay. But it says let's add 2 more rectangles to this one.
Miss Wendy.
Yes.
Hey, could you hit resubmit on your attendance, please? It's not pulling through.
I'm sorry. We got started and forgot to do it. Okay. All right, so let's take just a second. We're going to let that rectangle keep growing in just a second. We were watching that video, weren't we? That science video. That's what got me thrown off. Well, okay, there we go, and lunch. When breakfast was tea. There we go. Alright, sorry about that interruption, but had to be done. Had to be done. Okay, so we see the area of this rectangle. Now it asks us to add on to the rectangle. Let's add 2 more rectangles to this one. Now this is what they mean. Let me show you what they mean. One with a length of 30. So let's add on this one and we'll make its length 30. And the other with a length of 4. So we'll make that even just a little bit smaller. Okay. Now they all have the same width. This rectangle is 8 in width and 200 in length. This rectangle is 30 long but 8 wide. Do you see that? It still has that 8 right there. Because remember how opposite sides of a rectangle are the same? Okay. So this rectangle would also have 8 for its width and 4 for its length. Okay. Now, how would we find the area of just this rectangle right here? I'm going to make it a little bit different color so we can see it. If we wanted to find the area of just that rectangle, what would we multiply? Y'all know to multiply the length times the width. What would we multiply? Go ahead.
8 times 30.
Yeah. See, we have to remember the 8 is here. This and this and this are all the same size. Okay, they're all 8. So 8 times 30, which would be, what? 240? Okay. Now what about the last rectangle, that smaller one on the end? Thank you. That smaller one on the end, what would we multiply to find its area? Remember, this is 8. Miranda, what would we multiply?
8 times 4.
8 times 4. Okay. So this is 8 times 4. Which is what, everybody?
32.
Okay, 32. Gotta wake up this morning. Alright, so we have the area of 3 different triangles. Rectangles. Okay, 3 different rectangles. What do you think we would need to do if we wanted to know the area of the whole thing? Say it real loud. Add the areas up. And she's exactly right. So we have 1,600 or 1,600 plus the 240 plus the 32. And if we put those all together, we'll have the area of the whole thing. Okay? So this is 2, this is 7, 8, and 1. 1,872. You know what you just did? You just used the area model to multiply 234 times 8. 234 times 8. 234 times 8. That was using the area model. Okay. Now let's use standard algorithm and see if we got the same answer. 8 times 4 is
32.
32. We said that a minute ago. We'll put the 2 and carry the 3. Not but the 3. 8 times 3 is what?
24.
24 plus 3 more.
27.
25, 26, 27. Put the 7, carry the 2. And 8 times 2? 16, 17, 18, 1,872. Okay. All right. So let's try this one. Go ahead and get out your whiteboards, your markers, and erasers. Okay? Put those out of your backpack. We're going to work through this one together. Okay? That belongs to the school. We can use it every day. Grab a pencil. Here you go. Okay. Pencil. I can't hear you. All right. Now we have 316 times 4. 316 times 4. Now what I want to show you, don't write anything yet, okay? What I want to show you is how you would set this up with the area model. If somebody gave you a problem like this and said you have to use the area model to figure it out, this is what we would do. We're going to draw that rectangle to show our larger number, okay? How many places does this number show? This number right here. How many place value places are there? Yeah, there's just 3. There's the ones place, the tens place, and the hundreds place, right? So we need a rectangle that's going to show each of those places. So our rectangle will have how many sections in it? 3. Okay. So we're going to draw a rectangle. Kind of long. It almost looks like we're about to draw a tape diagram. Okay, I'm going to redraw my rectangle. I was actually going to erase this. Okay, so on your whiteboard, I need you to draw a long, thin rectangle, but you need to have room to write above it. Inside of it, it does not need to be so tiny that you can't draw in it. Okay, you're going to have room on the sides as well. Okay, you need room all around that rectangle. Okay, so we're going to divide this into 3 sections. And a lot of times when you see the area model cut into pieces, they put a larger piece for the hundreds place, maybe a more medium-sized piece for the tens place, and a smaller piece for the ones place. So if we cut it, maybe about there and about there, it's not going to be perfectly exact. Okay. But we need 3 sections for our 3-digit number. Now, it's almost, an expanded form when we pull a number apart. It's similar to that. We're going to pull this number apart into the hundreds, the tens, and the ones. So, up above our large piece, we're going to write 300. Because there are 3 hundreds in that number. Okay, go ahead and doing this with us. All right, so if I did that above my first piece, what am I going to write above that second piece? What would make sense? Yeah. If we put a 10, because there's only one 10, isn't there? Okay, so make sure you're doing this with us. Okay. Alright, so what would make sense to put above the last piece?
6.
Yes, a 6. Because there are 6 ones. So this is just showing our hundreds place, what we have there, the value of our tens place, the value of our ones place. Okay. Now on the other side, right here, I'm going to put the number that I'm multiplying by. And what are we multiplying by? It's right there. 4. So that goes right here. Remember how rectangles work. The opposite sides are equal. So if this is 4, then how long is this?
4.
And how long is this?
4.
And how long is this?
4.
They're all 4. They would all be the same. I don't have to write that every time. Okay. Could you? Yes, but you don't have to write it every time. Okay. Now I'm just going to do my multiplying like I did to find this rectangle over here. 4 times 300. We're just finding this piece right now with 4 times 300. Okay. What would 4 times 300 be? 1,200. Some people might write, let me just show you that other way as well. Sometimes you might see the problem right here. I have a pen. 4 times 300. And underneath it, you might see the answer. Okay. And I'm going to do it that way right now just to show you what we're multiplying. Okay. All right. What would go right here? What is our math problem right here for this method? Say it loud. 4 times 10. And we know that 4 times 10 is what, everybody?
40.
Okay. What would be our math problem right here on the last box?
4 times 6.
4 times 6. Which is? 24. Okay, we're all writing this down. Okay, we're all working together right now. And like Alexandria said a minute ago, we got to add all those pieces together to find the area of the whole thing. So I'm going to add some plus signs right here. Okay, and I know that when I add all that together, go ahead and add all that together. See what you get. We've got 1,200 and a 40 and a 24. Gotta make sure you line up your numbers correctly. 1,200 is a lot bigger than 40. Now, you should, somewhere on your board, have a little extra room. A corner, up high, down low, on the side, somewhere. I want you to come over to the side, or wherever you have that extra space, and I want you to write this problem that we just did in the way we would write it for standard algorithm. Okay? Just stack them like that. Put that on your board or your paper somewhere. And I want you to work that out with the standard algorithm because we're going to use that today to check our work. Okay. 4 times 6 is 24. Put the 4 and carry the 2. 4 times 1 is 4 plus 2 more is 6. 4 times 3 is 12. One of the other reasons we want to get pretty familiar with the area model is in another few days, we will be doing 2-digit by 2-digit multiplication, where we've got 2 numbers on the top, 2 numbers on the bottom. Okay, and we will also do the area model then, but the area model changes slightly when we do it that way. So we want to get comfortable with it when it's pretty simple. This is not so bad, is it? You're just pulling the number apart and you're multiplying the pieces and then putting them back together. It's similar to partial product, really. Okay. All right, so let's move all of this. You can clear off your board. Actually going to have us practice one more of these before we get to the word problem one. Okay, so let's don't write this just yet. Okay, we're going to work with that problem right there. And we're going to show it in 3 different ways. Okay, we're going to show it with the area model. We're going to show it with partial product. And we're going to show it with standard algorithm. Okay. So that means you're going to need some space on your board. So you might want to, let's turn our boards this way and cut it into 3 pieces so we can see all 3 of them. Okay. If you're working on paper, we're going to have these beside each other. Okay. All right, so we're going to start with area model. How many places does our number need? How many rectangles?
6.
Look at our number that we're multiplying. How many? 3. We would need 3. 1 for each of the place values. So here's our rectangle. I'll cut it. How much are we going to put above the first section? Remember, we're pulling this number apart into its place values. Valerie, how many hundreds do we have?
200.
We have 2 hundreds. Okay. Isabella, how many 10s do we have right there? 7. So 7 10s is how much? 70. Okay. Faith, how many 1s do we have in this number? 5. Caleb, what are we multiplying all of that by? Times 6. Okay, so that's what your area model looks like before we multiply. Okay. So what 2 numbers are we multiplying in the first box, Charlotte?
200 times 6.
6 times 200. What is 6 times 200? Brandon, what do you think? What are these 2 digits?
1200.
Exactly. So 1200. Or you could say 1200. Okay. What are we multiplying together, Gage, for this one?
70 times 6.
Yep. 6 times 70. What is 6 times 70 going to be? Yeah.
52.
No. What?
420.
420. Multiply the 6 times the 7 and get 42. And then add that 0. All right, what's our last multiplication going to be, Martin?
4 times 5. 6 times 5.
6 times 5, which is what, everybody? 30. And then we add those pieces together. Okay, let me give you a second to add those pieces together. At 1,200 plus 420 plus 30. All right, you've already got your space divided. I'm going to divide my space a little bit. Now, in your second section, we're going to do partial product. We haven't done that in a while. So let's walk through that together because just in case you're not remembering it. That would be 275 times 6. We're going to set it up like this. But remember, this is partial product. This is not standard algorithm. So write this problem like this in the second section. You're going to need room to write under it. All right, so partial product, here we go. Starts off the same as standard algorithm, 6 times 5.
30.
6 times 5 is 30. We're going to write that whole 30 right here. Remember, this was 6 times 5. We put these out to the side just to remind us of what we're multiplying. Okay. What would we multiply next? Be careful here how you say it. This is where partial product really starts looking a little different. What would be the next thing that we multiply? Yeah. 6 times 70. Which would be
42.
6 times 70. Close. 420. Okay. Gotta have that 0 with them. Okay. Everybody see what we've done so far? What would the next part be? What would the next part be? Yeah. 6 times 200. Okay. Because it's not just a 2 there, it's a 200. Well, that's supposed to be a multiplication sign right there. And that would be 1,200 or 1,200. What do we do with all those parts and pieces? Add them up. What do you notice? What do you see about these two different ways? Look at those two ways, whether it's on your board or on mine. What do you notice? We'll start us off discussing here.
For your answer, you have to add.
For both of them? Okay. We'll say one thing he's noticed is we had to add up parts to get the answer here. We had to add up the parts to get the answer here. Notice anything else or something different?
That the same answer that you got on this one is the same you got.
We got the same answer at the end. We got the same answer at the end. We did. What else do we notice? Anything similar? Anything different? Yeah. It feels like it almost both times, doesn't it? That we're stretching out that number. Yeah.
In partial product, you add the smallest number to the greatest number, and in the area thing, you add the greatest number to the smallest number.
Okay. Here we started multiplying with the ones place, didn't we? Here we looked at the hundreds place first. Okay, but it both got us the same answer, didn't it? Anything else you notice? Anything you notice about the parts? Yeah.
The numbers are backwards.
Okay.
Switch.
But they're the what? Same numbers. Same numbers. It has the same pieces and parts. We just added them in a different order. So when you add things in a different order, can you get the same answer? Yeah, if they're the same things we're adding. Okay, so we've seen those two methods. Now we're going to use our last section, and we're going to use the standard algorithm. So I'm going to make my third section. And we're going to start the same way. 275 times 6. So these two look similar when you begin. They don't look similar as we go. Okay, so write that problem one more time. We're going to do the standard algorithm. You may go ahead and work that out with the standard algorithm. What do we multiply first? It's been a long weekend since we've done these. What do we multiply first? 6 times 5. We go to the ones place first. What is 6 times 5?
30.
Okay. It's 30. We see that 30, but we don't write a whole 30 right there, do we? No. We put what here? 0, and we carry the 3 because it's like carrying 3 bundles of 10, 3 bundles of 10 dots over to the next place. 6 times what is next? 6 times 7, 42. But what about that 3? You got to add it. 42, 43, 44, 45. Put the 5. Carry the 4. Okay. And last, what would we do there, Faith? What would we do next? 6 and 2, which is what? No, that's adding them. 6 times 2 is... Everybody, what is it?
12.
12. 6 times 2 is 12. Plus 4 more. 13, 14, 15, 16. Okay. Anything we notice when we add this way in? Anything you say you notice? Yeah. We keep getting the same answer. Yeah. Say it one more time. We don't add. It happened kind of within the problem, didn't it? But we don't add the parts like we do here and here. Okay? All right, same answer. We carry. That's something different. Yeah. We carry over. Okay. We're going to see some things like that today in a little bit when we have a sheet like this. Or we're going to have the same problem all the way across the sheet. But it's area model here. It's partial product here. Standard algorithm here. Okay. All right. Let's go back. We're going to look at our word problem. Okay, you can go ahead and clear your board. Yes, we definitely need some space. Okay, if you're running out of space on your paper, you need to flip it over. You can do that. I feel like reading nice and loud this morning. Go ahead.
A cafeteria makes 4,408 lunches each day. How many lunches are made Monday through Friday?
Okay. This cafeteria makes this many lunches every single day that they're working. So how many lunches are they going to make Monday through Friday? Well, Monday through Friday is how many days?
5.
Monday, Tuesday, Wednesday, Thursday, Friday. It's 5 days. So what does our multiplication problem look like here? What? Yes. okay, because we're doing this 5 times, 5 different days. So it would look like, let's go ahead and write that. But we are making room for the area model, so you don't want to plop this right in the middle of your, okay. Now, because our new method today, right now, is the area model, that's what we're going to practice on that sheet coming to you in a little bit. We will be doing all 3 at least a couple times. Okay, 4,408. This one's slightly different because we've got a 4-digit number. Well, when I was doing the area model with a 3-digit number, I put 3 sections for my rectangle. With a 4-digit number, then, I would need to have how many sections for my rectangle? 4, because I need 1 section for each place value. Okay, so we're going to draw that rectangle. And we're going to cut it into pieces. Got a big piece for the thousands, a piece for the hundreds, a piece for the tens, a piece for the ones. Okay, let's put the number on the top, break it into its sections. We've got 4,000. How many hundreds do we have, everybody?
400.
Yeah, we have 400. What about 10?
0.
Okay, now I know sometimes, we're not going to be adding anything because of that 0, but if we leave that out, we have a bigger chance of getting something wrong. Okay? We have a bigger chance of forgetting that place has got to be there. So let's just put 0 right there. It's not going to hurt us to do that. And then we've got 8 ones. We're going to put the 8 above the smallest section there that are ones. Okay? What are we multiplying that whole large number by, Brandon? This whole large number?
5.
By 5. So that 5 goes here. So each piece gets multiplied by 5. Okay. What's going to go in our first box here? 5 times 4,000. What is 5 times 4,000? Miranda, what'd you get for that? 20,000. Got to be careful because that right there has its own 0 and then 3 more zeros. Okay. All right, the next section, Mason, would be what?
400 times 5.
400 times 5 or 5 times 400, which would equal what? 2,000. All right, everybody, the hardest part of this, 5 times 0 would be
0.
okay. Alexandra, what goes here?
40.
It does, but what's the multiplication problem?
8 times 5.
5 times 8, which is 40. Now put your plus signs in between all of those numbers. So you remember to add them up. And go ahead and add them up. Just make sure you line them up correctly. Now this right here is where I'm not going to put that 0 in there. If you want to, you certainly can. It's not wrong, but I know I don't have to add a 0 because that's not going to change my answer. Okay, 22,040. And what would we label this with? What was the final question they asked us? How many lunches are made Monday through Friday? And so, yes, this would be lunches. 22,040 lunches. Ooh, that's a lot of lunches. Okay. So I think you're seeing how the area model is working. Okay. It's really not difficult. It's just one other strategy, one other way. All right. Tell you what, we are ready to do a little practice and all that. So go ahead and clear off your board. And go ahead and put it away and lay your workbook out on your desk.